Tie. The tie that I chose is in the freshwater village, and its intended purpose is to hold the cantilever in place and connect it to the wall. The tie is most likely made out of galvanized steel. Galvanization is when you coat steel with a layer of zinc. This helps to improve corrosion resistance and make it suitable for outdoor areas near the beach. Galvanized steel is known for its unmatched durability and improved strength than steel. The tie's section profile is a round rod to evenly distribute the forces and prevent twisting or buckling. The tie is connected by bolts. The bolts secure the tie to the wall and allow it to be easily disassembled and assembled. The ties experience many forces. The main ones are tension and shearing. Tension is when two objects are being pulled apart, and shearing is when two objects are traveling or pushing in opposite directions. The structure could experience structural failure if excessive tension is applied. This will cause it to tear or rupture. Beam. Just what is a beam? A beam is a horizontal structural element that holds vertical loads. The beam I chose is in Freshwater Village. Its intended purpose is to hold up the weight above the walkway. The beam is made of steel. It is made from steel because of steel's high strength to weight ratio, and it is good for holding up heavy loads. The beam's square profile is an I-beam, and I-beams are highly effective in distributing loads. The beam's been painted to prevent corrosion and other unnatural forces. The beam is connected through welding to the roof, which is then held up by columns. The weld is called a butt weld, which is used to provide maximum strength. Beams experience many forces, such as bending. Bending is when excessive loads is applied onto something. The main way the design would fail is due to buckling. Buckling will occur if the beams are under compression or large loads for long periods of time. Strut. The strut I chose is in the Freshwater Village and is a structural component of a scaffold on a building. A strut is a diagonal member which is used to brace a square or rectangle. The strut I chose is most likely made of steel. Steel is a highly durable material and can hold out against tough weathers and large weights. It also has a high strength to weight ratio. The strut's square profile is a round rod. This is used to evenly distribute the forces and prevent twisting or buckling. The method used to prevent corrosion is painting. As seen in the photo, it has been painted blue. This is done to prevent corrosion and rust. The strut is connected through welding. It is welded to the rectangle and then the beams are clipped into the columns. This provides a strong permanent connection for the strut and makes the overall component easily removable. The strut experiences compression forces. These forces act along the length of the strut and push it inwards. The main reason the structure will fail is if the strut experiences buckling. This is when it bends or collapses due to instability. It would also fail due to excess compression. This would happen if it bears more weight than it can carry. Cantilever. What is a cantilever? A cantilever is a structural element that extends horizontally and is unsupported at one end. The cantilever I chose is located at the Manly United Training Grounds in Coma. The cantilever is most likely made from steel because of its light weight to strength ratio and its high durability. The cantilever's underside is a sheet section profile, while the sides and front are angled section profiles. The building uses a white paint to reduce corrosion and rust from occurring. The cantilever is connected through a series of ties which are then held up and connected to the node at the top, which then leads down to a column that runs into the ground. There is also a diagonal beam that connects to concrete blocks at the back, which help it held into the ground. The cantilever itself is bolted to the tie, and the undersection is welded to the bottom. The method has been used because it is the most effective and strong way to connect the cantilever to the ground. Forces that act upon the cantilever are mainly compression and tension. The compression occurs because the cantilever supports the roof's load, and tension occurs on the lower side because of the weight of the cantilever. The main way that this design would fail is if the forces were increased, like tearing, if there was excessive tension and shearing at the connection points due to excessive weight.